The vastness of space has always inspired humanity to look beyond the boundaries of our world, to wonder what lies out there, and to dream of journeys far beyond our reach. For decades, Mars has been the focal point of space exploration, capturing imaginations with its red deserts, enigmatic canyons, and tantalizing hints of water. Yet as our technology advances and our ambitions grow, the horizon of exploration stretches further than the Martian landscape. The future of space and exploration is not limited to Mars. Far from it. The possibilities extend deep into our solar system and even beyond, opening new frontiers and posing new questions about life, the universe, and our place within it. Humanity's quest to explore space is driven by curiosity, necessity, and the enduring desire to push the boundaries of what is possible. With Mars missions paving the way, attention is now turning to the outer planets, their mysterious moons, and the vast expanse of interstellar space. Each of these destinations offers unique scientific opportunities, challenges, and the potential to answer some of the most profound questions ever asked. One of the most compelling reasons to look beyond Mars is the search for life. While Mars remains a promising candidate for discovering signs of ancient microbial life, the icy moons of the outer solar system have emerged as perhaps even more tantalizing targets. Europa, one of Jupiter's largest moons, is cloaked in a thick shell of ice. Beneath this frozen surface, scientists believe there is a vast global ocean, twice the volume of all Earth's oceans combined. This subsurface ocean, kept warm by tidal forces from Jupiter's immense gravity, may harbor the conditions necessary for life. Robotic missions like NASA's upcoming Europa Clipper are set to launch in the coming years, designed to fly by Europa and study its ice shell, surface chemistry, and any plumes of water vapor that may erupt into space. The ultimate goal? To determine whether Europa's ocean could support life, and perhaps to detect the first signs of extraterrestrial biology within our own solar system. Saturn's moon, Enceladus, presents another compelling case. In 2005, the Cassini spacecraft made a stunning discovery: geysers of water vapor and ice crystals erupting from cracks near Enceladus's south pole. Analysis of these plumes revealed organic molecules and hints of hydrothermal activity at the moon's ocean floor, suggesting an environment not unlike Earth's deep-sea vents, where life thrives without sunlight. Future missions may one day fly through these plumes, directly sampling the material ejected from Enceladus's hidden ocean. Such a mission could revolutionize our understanding of where and how life might arise in the universe. Titan, Saturn's largest moon, is another world of extraordinary possibilities. While its surface temperature is far too cold for liquid water, Titan boasts rivers, lakes, and seas of methane and ethane, along with a thick, nitrogen-rich atmosphere. The chemistry on Titan is complex and exotic, raising the possibility of entirely different forms of life. Life that could be based not on water, but on hydrocarbons. NASA's Dragonfly mission, a rotorcraft lander set to launch in the mid-2030s, will explore Titan's surface and atmosphere, studying its chemistry and searching for clues to the prebiotic processes that may have shaped life on Earth and elsewhere. But the drive to explore goes beyond the search for life. The vast resources of the solar system present opportunities to support human civilization and enable even more ambitious journeys. The Moon, our closest celestial neighbor, is experiencing a renaissance of interest. International space agencies and private companies are planning a series of missions to the lunar surface, aiming to establish a sustainable human presence. The moon's south pole, in particular, is of keen interest because of its permanently shadowed craters that may contain water ice, an essential resource for life support, rocket fuel, and future exploration. Establishing a permanent base on the moon would be a monumental achievement, serving as a testbed for the technologies, habitats, and life support systems needed for longer missions deeper into space. It could also act as a staging ground for missions to Mars, the asteroids, and beyond. The Artemis program, led by NASA with international partners, envisions a return to the moon in the coming years, with the goal of landing the first woman and the next man on the lunar surface. The Lunar Gateway, a planned space station orbiting the moon, will support these missions and serve as a hub for science, exploration, and international collaboration. Beyond the moon and Mars, the asteroid belt beckons with both scientific intrigue and economic potential. Asteroids are the remnants of the early solar system, preserving the chemical building blocks from which the planets formed. Studying them can reveal clues about the origins of water, organic molecules, and even life itself. Moreover, asteroids are rich in metals and other valuable resources. The concept of asteroid mining, once the realm of science fiction, is now being seriously considered by governments and private enterprises alike. Harnessing the resources of asteroids could provide raw materials for space construction, fuel for spacecraft, and even rare metals for use on Earth, fundamentally transforming our economic relationship with space. Looking further afield, the gas giants Jupiter and Saturn, along with their numerous moons, are ripe for exploration. These worlds are complex systems with dynamic atmospheres, powerful magnetic fields, and diverse collections of moons, each with its own story to tell. Robotic probes, orbiters, and landers will continue to unlock their secrets, providing insights into the processes that shape planets and solar systems. But perhaps the most audacious vision for the future of space exploration is the prospect of interstellar travel, journeys to other stars. While current technology limits us to our own solar system, the discovery of thousands of exoplanets orbiting distant stars has fundamentally changed our view of the universe. Many of these worlds are Earth-sized and orbit within the habitable zones of their stars, where conditions might allow liquid water to exist. The search for life beyond our solar system has become a major scientific endeavor, employing powerful telescopes to study exoplanet atmospheres for signs of habitability and possible biosignatures. Projects like Breakthrough Starshot are exploring the feasibility of sending tiny, lightweight probes to neighboring star systems, propelled by powerful lasers. Such missions would take decades to reach even the closest stars, but they represent the first steps toward understanding what lies beyond the solar system. The ultimate goal? To one day send spacecraft, and perhaps even humans, across the interstellar gulf, transforming humanity into a truly spacefaring civilization. Establishing permanent settlements in space is central to the vision of a multi-planetary future. Space habitats, orbiting stations, and colonies on the Moon, Mars, or even the moons of Jupiter and Saturn could provide safe havens for humanity, protect against threats to Earth, and serve as springboards for exploration. These settlements would need to be self-sustaining, capable of producing food, water, and oxygen, recycling waste, and supporting human health in environments far different from our home planet. The challenges are immense. Radiation, microgravity, psychological stress, and the sheer distance from Earth all pose significant hurdles. Yet, with each passing year, advances in robotics, artificial intelligence, life sciences, and materials technology bring these dreams closer to reality. International collaboration will be essential to achieving these ambitious goals. Space is a domain that transcends national boundaries, a place where the shared aspirations of humanity can find common ground. The International Space Station is a shining example of what can be achieved when nations work together, pooling resources, expertise, and vision. Future missions to the Moon, Mars, and beyond will depend on similar partnerships, as the scale and complexity of these endeavors far exceed what any one country can accomplish alone. Private industry, too, is playing an increasingly vital role in the future of space exploration. Companies like SpaceX, Blue Origin, and others are developing new rockets, landers, and spacecraft, driving down the cost of access to space and opening new opportunities for research, commerce, and even tourism. The dream of ordinary people traveling to space, once unthinkable, is now within the realm of possibility. As commercial spaceflight matures, it will complement government-led exploration, accelerating progress and expanding humanity's reach. Looking even further ahead, the technologies developed for space exploration may one day enable the terraforming of other worlds, transforming hostile environments into places where life can thrive. While such feats remain speculative and far in the future, the pursuit of these grand challenges continues to inspire new generations of scientists, engineers, and explorers. The journey beyond Mars is not just about reaching new destinations. It is about understanding our universe, searching for life, harnessing resources, and ensuring the long-term survival of our species. It is about the enduring human spirit, the desire to explore, to learn, and to imagine a future where the boundaries of possibility are forever expanding. The future of space exploration promises discoveries we cannot yet imagine, challenges we have yet to face, and achievements that will redefine what it means to be human. As we set our sights beyond Mars, we are embarking on the greatest adventure in history, one that will shape the destiny of our civilization for generations to come. The stars await, and with them, the answers to questions as old as humanity itself.